second and final session about trend descriptive analysis. I have the great pleasure of introducing Dr. Jason Liu, who is an associate professor at the Institute of Public Health here at NYCU. He obtained his PhD and master's degree from Harvard University, and his research interest focuses on cancer epidemiology. Welcome, Dr. Liu.
Okay, thank you, Lila, for your introduction. And good day, everyone. Can you all hear me well?
You clearly, Dr. Liu.
Okay, great. Okay, great.
Yes.
Okay, so today I'll be talking to you about how to, like, the basics of trend analysis with the Joinpoint Regression program. And because this is the webinar on strengthening health systems, I wanted to see how this topic I'm presenting today fits under the World Health Organization's health systems framework. And as you can see here, we have 6 building blocks of a health system, according to the WHO. And the topic that I will be presenting today fits under the health information systems building block. So here's a summary. So it's from the same document of the previous slide, and shows a summary of the core indicators and scoring for Health Information Systems Performance Index. And it mentions certain key terms like the analysis of health statistics and routine reports on vaccinations and a burden of disease study. So basically, for a trend analysis, we can definitely examine vaccination use over time, as well as examine the incidence of disease over time to evaluate the burden of disease in a population over time. So definitely the topic of the trend analysis fits under the framework for strengthening health systems. So why do we conduct trend analysis in public health? So there are several reasons. The first is to understand changes in health-related exposures, disease incidence rate, or disease mortality rate over time. And in terms of health-related exposures, it could be exposures that are health-promoting, such as vaccination use, or it could be exposures that are detrimental to health, such as the use of cigarettes over time. And as I mentioned previously, looking at the trend of disease incidence and mortality over time can give you a sense of the burden of the disease in a population over time. A second use of the trend analysis is to predict trends in the future. And for this session, I won't be talking to you about how to predict trends in the future, but we have there are statistical methods to be able to predict trends in the future using current trends. So that's something that can be done to project future disease burden. And then the third point is to generate hypotheses to understand factors driving these trends. So by examining the patterns of disease incidence over time, we can generate hypotheses to understand the causal factors driving these trends. So to promote future studies to further understand what are the causes of the shapes of the trends. So here's an example of a health-related exposure trend. So we see here, these are the tobacco product use for high school and middle school students in the US. And as you can see, we have any tobacco product on top and e-cigarette use, and at the bottom for a trend from 2011 to 2018. And it's to show that e-cigarette use has been increasing in high school students over time. So definitely by looking at this, we can generate hypotheses about what are the factors driving these trends. And then here's an example of disease mortality trend. So this is the trends in infectious disease mortality in the United States during the 20th century. And on the y-axis, we have the mortality rate per 100,000 people. and then it's from the early 1900s to the late 1900s. And you can see the mortality trends from all causes, non-infectious causes, and from infectious diseases. And anyone knows like what's the reason for the spike here? Yeah, so it's because of the 1918 flu. So if we continue to plot this trend, we might see another spike in 2020 because of the COVID-19. So the mortality rate in 2020 maybe is especially high. So this is an example of disease mortality trend. And then we can also have disease incidence and mortality trends plotted together. So here we have the age standardized incidence and mortality rates for cervical cancer among women 30 years of age or higher in Taiwan from 1980 to 2006. So here on the y-axis, we have the age standardized incidence and mortality rates of cervical cancer for 100,000 people. And then we have the year from 1980 to 2006. So as you can see here, the in situ incidence rate increased dramatically in 1995, and it's because in 1995, free mass screening of cervical cancer became available in Taiwan. So that's why people underwent screening, therefore driving the in situ incidence rate. So sometimes the explanation for trends can be pretty obvious, like in this case, or for the case previously regarding the 1918 flu pandemic. So sometimes it's easy to explain why we see certain shapes in the trends, but other times it can promote future studies to better understand why we have certain shapes. So here's an example of the disease incidence and mortality trends. And we have the in situ invasive incidence rates and the mortality rate of cervical cancer in Taiwan. Okay, so we see all these lines, right? But then how do we best quantify the changes in trend? How do we know if these trends are statistically significant? And how do we quantify how much the trends are increasing or decreasing over time? So here we have a traditional linear regression. And it seems like this regression line fits the data pretty well, right? But at some places, for example, at the top left, you can see that the line doesn't really fit the data as well as it can fit the data. So are there ways to improve the fit of the data? So the National Cancer Institute from the National Institute of Health in the US, they developed this Joinpoint trend analysis software. And what it is, as it's shown here, is that Joinpoint is a statistical software for the analysis of trends. Trends using Joinpoint models, and in this model, several lines are connected together at the joint points, which I'll show you at the next slide. So here we have on the left side, we have the graph that I showed you previously, and we have no joint points here, so it's just one simple line. It's like an ordinary linear regression fitting the data. But then we can have 3 joint points. And then, as you can see, in 1995 and in 1998 and in 2008, we have 3 joint points, which allow us to fit the data much better. So the joint point program, through the use of the joint points, allow the regression line to be able to fit the data better than just using a simple line. So we can see from this example how the fit on the right is much better than the fit on the left. So how does this Joinpoint software select the joint points in the final model? So I won't be going through the details here, but you will be able to read more about it at the website shown below. So if you click on the link below. They have a detailed description of each of the methods they use to select the final Joinpoint model. But the default model that they use is the permutation test, which is the first one shown here. So if you don't do anything, then it's the default method, and it's the method that has the longest history of use. So so it's perfectly fine to use that. But if you go to the website shown on this page, it describes all the other methods to give you suggestions of what like for example, if you want to use the BIC method, why you should use it and what are the advantages of using it. So please go through the information on the website below. So basically, using these methods, they'll be able to select the number of join points for you. So sometimes if you use the join point model, it doesn't select 3 join points. It might still give you 0 join points and think that the straight line is the best fit. So it depends on the results of these statistical calculations to decide in the end what's the final model for the joint point regression. Okay, so for the number of joint points, we have the default number shown here. So as you can see, as the number of data points increases, the default maximum number of joint points also increases. So if you have 0 to 6 number of data points, then the default maximum is just 0. Because if you have so few data points, then it doesn't really make sense to have all these twists in the data, like the twists in the lines. So they think that 0 joint points is sufficient for data points with just 0 to 6 points. And if you have more data points, like 27 or plus, then the default maximum can be up to 5. But like I said before, it doesn't necessarily, like if you run the joint point program, the suggested number of joint points might not actually go up to 5. It could give you 3 joint points or 2 joint points. So so the mathematical calculation will provide the suggested number of joint points. And you can actually tweak the number of joint points yourself as well. But typically when I use this kind of analysis, I just follow what they provide me. So and their recommendations are basically based on this table. So if you have few data points, they will never suggest like 2 joint points. If you have a number of data points, like if you have 3 data points, they'll never suggest the maximum number of joint points being 1 or something like that. So they'll always adhere to this table. So in order to quantify the changes in trend over time, the Joinpoint Regression program uses these 2 measures, the APC and the AAPC. So the APC is defined as the annual percentage change, and it's calculated by fitting a least squares regression line to the natural logarithm of the dependent variable, which is the variable on the vertical axis. And then calendar year is the independent variable, which is the variable on the horizontal axis. Okay, so that's the calculation of the APC. And on the next slide, you'll see much better what I mean. And for the AAPC, because if you have 1 joint point, then you'll have 2 APCs, because there will be a shift in the lines. So there has to be a way to average all the APCs. And you'll see much better in the next slide. So AAPC is basically a single number which summarizes the trend over the study period, and it's the weighted average of the APCs. And the weights are equal to the length of the APC interval, and the length is measured in the number of years. So here's an example that will let you really understand APC and AAPC well. So basically here we have the formula for APC, and because the y-axis is on a log scale, we need to exponentiate it to have a to get the percentage change over time. So APC basically equals to e to the power of b, and b is the slope, okay, slope of the line, -1 times 100. So here's an example. So APC from 1995 to 2003. Here we have APC equals 0.7, right? It's a purple line on the right. So the slope is 0.007. So in order to get the APC, we just exponentiate the slope. So e to the power of 0.007, and then we minus that by 1, and then we multiply all that by 100. So we get that the annual percentage change from 1995 to 2003 is 0.7%. So it's a simple formula to get the APC. So 0.7% change on average from 1995 to 2003. And as you can see, it's a positive slope. So the change is also positive. And then to get the weighted average of the APCs, we have this formula here. So here's an example to show how the AAPC is calculated. So here we have AAPC from 1994 to 2003. So 1984 covers one part of the APC from the green line, right? Because the green line goes all the way to 1995. So it covers 1 year of the line of the green line, okay? And then from 1995 to 2003, that's basically the purple line. So the slope of the green line is negative 0.113, right? So we have here negative 0.0113 in the formula, and then multiply by its weight. So the weight, as I mentioned before, is the number of years. So the green line contributes 1 year. Okay, so 1994 to 1995, it's just 1 year. And then we plus we add the contributions of the purple line. So the purple line contributes 8 years. So the weight is 8. And the slope of the purple line is 0.007. Okay, so we basically just plug in the weight, which is the number of years, and then the APC, okay? And then we just divide that by the total number of years, which is 9 years. And then we can get that the AAPC from 1994 to 2003 is negative 0.6%. So this is a way to summarize all the APCs, because as you can see here, there are 1, 2, 3. So there are 3 joint points, meaning that there are 4 different lines with 4 different APCs. So if you just have 0 joint points, then the AAPC will equal the APC because there will be no shifts in the slope. But whenever you have joint points, then you'll have different APCs, and the AAPC allows us to summarize all the APCs. So here we have 4 APCs, and if we want to calculate the AAPC from 75 to 2003, it's also possible. But then this formula will be a little bit longer, because then you'll have the weights of 13 here, the weights of 4, weights of 3, weights of 8, and then all the different slopes will have to be plugged into the formula. So it'll just be the same formula down here, but much longer. And then the total number of years contributed would be 13 plus 4 plus 3 plus 8. And then you can get the total AAPC, which should be 2.4. And the little star next to the 2.4 just means that it's a statistically significant AAPC. Okay. So the Joinpoint software is very convenient to use because it's free to download with very comprehensive instructions online. And what's nice about it is that it also contains a built-in sample session, like built-in sample sessions for practice. So if you click like the options within the program, you can actually call out this sample session with data already inside for you to practice. So there's actually no need to import your own data there's no need to import your own data into the program for practicing. You can just use the sample session for practicing. But of course, we'll show you how to import your own Excel spreadsheet data into the software. So the Joinpoint software is also compatible with Excel spreadsheet data. And in addition to being able to calculate the AAPC, it can be used to calculate the H standardized rates, which is helpful when we're comparing the rates across different populations, because different populations might have different age distributions, and you want to be able to have a standardized rate based on either like the WHO world standard population or based on like the US standard population, etc. So it'd be more helpful to compare the data between different populations. So in today's lab demonstration, which will be led by Edo, and he's actually experienced with using the Joinpoint program because he recently won a poster award on a research project which involved analysis using the Joinpoint program. So he has experience with this program. So he'll show you how to import Excel spreadsheet data into Joinpoint program, and then how to obtain the age standardized, or also known as the age adjusted rates, and how to generate the outputs and graphs from the Joinpoint program, and how to interpret the results. And as I mentioned before, there's comprehensive help information online. So if there's any questions you might have regarding the use of this program, you can always refer to the link shown below here. So it's a very user-friendly program with a lot of help documentation. So it's very easy to use. Okay, so thank you for listening to my presentation, and please let me know if you have any questions.
Thank you very much, Dr. Liu, for that very accurate description and sharing your knowledge about Joinpoint software. Feel free to leave your questions in the chat box to all participants. So now we will move on to the teaching assistant demonstration. Please help me in welcoming Mr. Edo Riandani. He's a second-year graduate student from IHP, and he is from Indonesia. So welcome, Mr. Edo.
All right, can you see the screen for all participants? Okay, good. First of all, one of basic problem that I face, or maybe some of user face when we are operating the Joinpoint, is to import the data from the Excel to the Joinpoint itself. So basically, we need to make sure that our data are structured well, that will be accessible to Joinpoint to read each variable, so there will not be error in determining the variable. So this is the glimpse of my Excel file, which is in this file. I would like to analyze the trends of the lung cancer incidence in the United States. This is the lung cancer incidence rates with the difference of the race. So here I will use the data from the 2009 to 2018 as the comparison for the trends in lung cancer. And for the race, I use it 4 different category in the race. 0 refer to the white, 1 refer to the black, 2 refer to the Native American, and 3 refer to the Asian American. So from this data, we can import it from the Joinpoint software. First step we need to do is to open the Joinpoint regression program. So I think the previous day we already submitted the link. So probably now you already have it on your desktop. The first thing you need to do is to click on the file, and then you need to click also the new session here. So the new session here, you need to upload your Excel file. I put my Excel here, and then this was JSON. And I'm sorry, yeah. So everything's clear. Now here is my first page of the Joinpoint analysis after I imported my data. So refers to my Excel file. Before, I have the 3 different variable here, which is the year, race, and also the lung cancer incidence rate. So for the lung cancer incidence rate, I have already calculated previously. So I'm not using Joinpoint to calculate the lung cancer incidence rates. So first of all, this is our first page. there are three different button or option in our page. First is input file, method and parameter, and advanced analysis tool. So we need to focus first in the input file. For the input file, we need to determine which one is dependent variable and which one is the independent variable. For the dependent variable, because I want to see what exactly the trend in the lung cancer incidence. So my dependent variable will be the lung cancer incidence. And as what I mentioned before, that I already calculate my data. So I will just say that my type of the data will be provided in my data file. And type of variable here, I use the crude rate. So later I will also show you how to calculate the age-adjusted rate. And for crude rate here, I use the lung cancer incidence. Moving forward for another variable, which is the independent variable, mostly or commonly in the Joinpoint program, the independent variable is referred to in the year because we want to know the trends for every single period of year. And because this year, of course, the interval type will be the annual. So we can change it with the monthly or daily or other based on our independent variable. By variable here, I have the arrays variable to be as my category. So I will click on it in the arrays, and I will define what exactly the category in my race, because I have four different category. 0 is for white, and then 1 is for black, 2 is for the Native American, and 3 is referred to the send. I can just click OK. Right, good. So next step is we need to also choose the heteroscedastic or correlated. So basically, for more information about this, as what Professor Jason mentioned before, we can just simply click on this, what are the options. So it would refers automatically to the Joinpoint website. So we have more explanation for every single categories in this section. So basically, we need to find out in this part is how to assume that the error of the regression model is homoscedastic across all values of the predicted values of the dependent variable. So if we have the standard error in our data, we can just click on the standard error, which is provided in our data. But because in my data, I don't have any standard error, so I will just choose the constant variance. Again, for all these four categories, for more better understanding, you may check it on the website, the Joinpoint, which is also available directly on this sentence. So I will choose this. And also I will choose the uncorrelated for the choose an error model to fit in. Then for log transformation, there's two different log transformation here, which is first option is no log transformation and the other is yes. So basically based on the Joinpoint, they suggest us to choose the yes, because in case of lung cancer incidence or when we analyze about the cancer, it belongs to the rare case. When we use the no transformation, somehow it will result in the skewed distribution. But when we use the log transformation, it will result in the normal distribution. So it's better for us to use the yes log transformation. All right, for the method and parameter here, I would like to use the default program. But if you're really interested to find out what exactly in the option they offer for us, it's again, please read the explanation in the Joinpoint website. So I would just simply click on the thunder symbol here, which is this is the execute current session. Wait for a minute, and yeah, we got our result here. So for all of my category in the race, I have one Joinpoint. So I will click on the one Joinpoint for the white, black, Native American, and Asian American. So from here, we have the different and diverse line, which is representing about the diverse trends of the lung cancer incident rate in the different of the race. From here, from just visual observation from the graph from 2009 to 2018, we can observe that almost all the race showing the declining trends in the lung cancer incident rates. Somehow, we're not really sure which one of these race has the more magnitude or has more power or has more higher in declining trends in the lung cancer. So we can check it on the trends over here. If you're interested, you can check on the data here showing our data, and then the model estimate what model that we use. And then for the trends, it's focused only on understanding the trends. So as what Professor Jason mentioned before, we may focus on the annual percentage change and also the average annual percentage. On the annual percentage, I will take one example in the white here. For the white here, so the annual percent change, it's referred for the specific period when there is a joint point or a change. It doesn't matter, it doesn't necessarily to be like whole period of the observation, no. As long that the joint point found that in the several years there is a change, it will conclude it as the annual percent change. For example, in the white here, from 2009 to 2016, it found there is the decreasing trends of the lung cancer incidence, which is minus 2.1, and then it continued in 2006 to 2018. It keep decreasing in minus 4.0. But for the average annual percent change, because we want to search more about the whole duration or whole trends for our analysis, well, say I will take one example for the black. For the black, it shows that for full range, so as for the 2009 to 2018, there was a declining number of minus 3.1%. So from looking for the annual percent change here or APC, we can determine that the black the black stand as the highest race category, which has the highest declining number in the lung cancer incidence rate, looking for the APC. And the stars here indicate the significance of the trends by the p-value, which is the lesser or equal to 0.05. All right, that's the first section, how to import our data from the Excel to the Joinpoint. So the section here, I would like to introduce about how to assess or analyze the age-adjusted rates. First of all, I would like to refer from the website from the National Cancer Institute. Okay, I will stop sharing first. I think there's. All right. Okay, so here is the website from the National Cancer Institute. This website, the specific website, provide a brief and really detailed information about how to use Joinpoint. So it's really better for us, again, to check for all the description explanation if we really interest in how to understand the trends for specific disease. So for analyze or compute the age-adjusted rate in Joinpoint, we need to create the Excel data that's suitable and compromise about the several variables over here. Again, for Joinpoint to compute the age-adjusted rate, each input data record must have the following variable in this order. So it was in the capital word. So it's really important to create the variable in this order. First is for the all cohort defining variable. Second is the independent variable. The third is the adjustment variable, which is typically an age variable in the groups. And the fourth is count. Count refers for the number of the cases of the disease. We can use the case of the cancer. And the fifth is the population, and the sixth is the standard population. So without further ado, I would like to show you how to analyze it on the Joinpoint regression program. I will stop sharing again and back to the Joinpoint program. Wait a minute. All right, we arrive in the Joinpoint analysis program again. So I will close my first section. I will open my new section. So for this section, for the saving time, I will just use the sample section that is provided by the Joinpoint. The difference is the first section, I utilize my own data set, which I created before. But for this section, I utilize the section or the file that already well established from the Joinpoint. So it's simple, we just need to click on the file here and we click on the sample Joinpoint session. Sample Joinpoint session. And there's a 4 different sessions that probably we can use it for practice in understanding the trends. Because I'm interested to show the age-adjusted rates, so I will go to the third line over here, age-adjusted rate calculation and the regression analysis. All right, so this is our studio, our first page. In the input file, we can see because it's automatically provided by the software, it's already templated well for every single categories. So for analysis, as what I also mentioned before on the website, we need to put in the order for the variable, for the sex, year of diagnosis, age record with less than 1 year, age-adjusted rate, count, population, and standard population. So here, for the dependent variable, here there's a basic or the main difference when I calculated in comparison with the previous one. The previous one, I used the provided in the data file because I already counted. But for this, I want this Joinpoint to count my dependent variable. So I click calculator from the data file. So type of variable, we can choose crude rate. When we choose crude rate here, we doesn't need variable to compute the age-adjusted rate for sure here. Only count variable and population variable. But when we choose the age-adjusted rate, it automatically pop up the several variables that we must use to count or calculate the age-adjusted rate. So count variable, its count is referred for this column, and then population variable population. Adjustment variable is age report, which is also referred for this column, and standard population, also standard population, which is referred for this column. Year of diagnosis, which is the independent variable, it's always been the year or the duration time. And for the sex here, we can define basically over here again, but they are already defined also because it's sample section. So 0 is male and female, 1 is male, and 2 is female. And because for the heteroscedastic or correlated error option, they have the standard error data, so they will count the standard error based on the data availability. So they also choose an error model to fit, which is the uncorrelated. Again, if you really interested to know what's different between the error models to fit, check on this blue sentence. There will be like a really brief explanation about it. I will go with the method and parameters button over here, and I will just keep it in the default. But a little bit difference here, we can, as maybe in the previous section in the lecture, that we can choose our APC segment reach. So, excuse me. All right. Okay, so we can choose our range here. So whether we want to use the range for the whole range of our observation year, or we want to separate it based on our interest, whether we want to use it like every 5 years or the last 10 years. So it's basically fine. So we can just make everything as default, and then simply click Thunderbolt here, and then it will direct us to the execute current session. A minute, and we have this. So this is our result. In the male and female, we have a 3 Joinpoints result. So interesting to know about much more Joinpoint in the 3 Joinpoint. We can click on it. So we can see that for the male and female trends picture, and then for the male and also for female. So from the visual observation, we can define that male has a higher trends for the diagnosis of the cancer from 1993 to 2013 in comparison to the female. But again, to make sure that our data or our observation is correct, we need to see the precise number in the trends, which is presenting by the APC and also APC, sorry, for the APC and also the AAPC. So for the APC, I will take one example again for the male here from the 3 Joinpoint. So the computer or the software defined automatically whenever there is a difference of the trends for particular years here. And then for the average annual percent change, it will give us the full range. Let's say like I will choose the male over here, full range for 1993 to 2013, which indicate that is minus 2.3 through trend, which is declining. And for male and female, it's so that it's so that I will scrolling down. Okay, thank you. It's so that male has for the full range, male has the higher declining number in the overall cancer for from the 1993 to 2013. So I think that's a brief explanation about how to use the Joinpoint regression to analyze the trends. Hopefully it could help all. And again, if we are interested more in the Joinpoint analysis, we can just check on the National Health Institute data, our software, or the website, so we can have the more explanation about it. So thank you very much for the time.
Thank you so much for that explanation, Mr. Edo. I will also like to open up the Q&A session now. So Dr. Jason Liu, We have a question from Dr. Hernandez from Guatemala. He asks, can we use this tool only for cancer data or for any kind of disease or other situation?
Okay, thank you for your question. Definitely, this can be used for any type of disease, not just for cancer data. Yeah, so you can use it for cardiovascular disease data, infectious disease data, anything. Yeah, so it's really flexible.
Okay, thank you, Dr. Liu, for sharing that answer, and I hope we all can appreciate just how versatile this program is. So with that, I conclude today's session. I hope that today's session has proven to be useful in your countries and relevant areas of expertise. Our aim is to assist you all in strengthening your healthcare and disease control system. As a reminder, tomorrow's agenda, we will be discussing public health strategies for pandemic, as well as age period cohort analysis and difference in difference analysis. Once again,